So hello everyone, in this YouTube video that I'm going to show in which I'm going to show you how the method that I propose to solve this problem, which is entitled check if move is legal. It's a Leetcode problem that was on the 58 biweekly contest. So the interesting thing about this problem is that is in fact how I tried me specifically to resolve it. I found it really interesting because my method is really very close to brute force. I tried to it's not like brute force, but in which I tried to implement everything separately. I tried to make three problems, and for you who are after only the code, I will put the link of this code in the description. The code is in a GitHub repository that you will find the link in the description below. So let us continue about with this problem. So the first thing we're going to try to do is to understand the problem. So the problem starts like this. You are given a 0 indexed 8 by 8 grid board. So you are given a board like this. This board is this board contains cells that are determined by R and C, row and column, presented by points. Free cells, we have three different types of cells. The first one is free cell, which is represented by a dot, and W for white cell and B for black cells. So what we are trying to do in this algorithm or in this problem is to find or to check if a move is legal or not. A move can be legal in case we have a sequence like this. The color of the we are trying first in this algorithm we are given first the row and the column. That means we are given a free cell. This we are and the color, to color that free cell we are going to change the dot with a color either white W or black B. So given the fact that we are always coloring a free cell, we need to check if the move is legal. The move can be legal only if there is at least at least three cells or more cells that started, taking in consideration the first cell, which is the free one that we are going to color, taking in consideration that one and another one which goes the same color, and in between them we have the different colors. This is mean basically something like this: black, white, 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 black, or black, white, black. At least that means black and only white and then black. That's how we can tell if a move is legal. So let us see these examples now to understand what good line. The move is legal. That means that we have a good line. A good line can be like this: black, white, white. We have a good line with the black and the points, and then good line with the white and the points, white, black, and white. This has no good lines because we don't have a sequence of two different colors, sequence of two different colors basically. Here we have diagonally. We can go also diagonally, horizontally and vertically. We have like these two examples: good line of good lines, starting with two whites and the points, and here with two black and the points. So this is an example that we are given. If we try to draw this example, we're going to have this board. So with this example, in this example we should have as output true. meaning that the move is legal because we have two options. That's been said. Now we are going to check to check the algorithm that I created. So I'm going to go directly to the code. Here we go. I called the class legalMove.java, the file, and the class is named legalMove. So here, the code that or the solution that I made is composed of three methods. The main method, or the method that we are the important that we run in Leetcode is check move. The other method is check move one direction. The other one is rotate matrix. So the idea of my algorithm is that every single the idea of this algorithm is we're gonna check only move in one direction. This means basically something like this. We are going to check if the move is legal on this direction only, and then on this only direction, and then on this only direction, and then on this only direction. This means basically that we are going to check the move on each direction separately. We have 8 directions, this one, and the others. Okay, so to do so, I created this method renamed rotate matrix in that for these parameters will give us or will tell us if will give us a linked list composed of the characters that we are going to have in a certain place. This means basically that if we take the method, okay, let me do this so that the method takes as arguments b the board, int, and c the coordinate of the cell, the empty cell, and round the number that tell us in which direction we are going to take. I give this int number that tell the round that tell us which direction. Basically, if I give 0, it's this direction, 1 for this, the next one, 2 for this one, 3 for this direction, and 4 for this direction, etc. So basically, if I give it 0, it will give me this direction. It will give me dot, white, w, and black. This is the output of this method for these arguments. How this method exactly works, let us check. So the first thing that I did is I created the linked list in Java. This is in this linked list is firstly empty. Then I used this switch, and then for number for an option between 0, 1, 2, 3, 4, 5, 6, and 7, I can give back an output. So the first thing that I did is that I created this is basically just like saying for int e. This thing here, int stream dot run c to 8 for each. This basically is just like creating something like this for. Okay. Yes, this is it. This is it for g equals 0. No, equals c. B is 8. This is basically this loop for here do the same as this code. I use it instead of this one and int stream because I found it's faster. It gives me a faster time. So this is just an optimization of the code, and you should learn the stream API for Java 8. It's been for a long period, and it's very helpful in competitive programming, especially if you are working or familiar with Java. I know that many people are familiar with C++ and Some people are familiar with Python, but I prefer to work with Java. It gives me too many options, and also it gives me a very good runtime. So this is it. I use this one. I created a stream of integers. This stream basically starts from 6, from C, the value of C, to 8, and for each value of this stream, what I'm going to do is to add to this linked list. I will add the value that is in the coordinate BRI. So this is how it works. So let me explain for this example, no, like this, how this code works. We started by C. The first value of I is C. So if we take in consideration that this is C, this is the column C, which has the value C. So we are here in this column, in some place in here. And the thing that we are going to do is that we are going to add a linked list the value of in the board which has this coordinate R and I. So we are always in R is a fixed value, so we are here. If we take in consideration that we are in here and we are starting from this column, that means that we start from this point, and we are going to add to the linked list this value, then I going to increment by 1, and so we are going to the next cell, which is this one. We are going to add the value of this one, which is WY, stands for white, then this one, then this one, and we are going to end by this one, exactly by this one. And I'm going to do the same for this one, but this time for the other direction. How this works exactly, how I pick the 7 minus R instead of C, let me show you. No, I'm sorry, it's not in this direction, it's in this direction. As you can see, I is going to increment started from the value 7 minus R. So we are going to give to I the value, the first value is 7 minus R. So here we're going to have 7 minus 7 plus R. So 7 minus 7 plus R gives us the value of R. If we incremented R by 1, we are going to have I by 1, I'm sorry, we are going to have 7 minus 7 minus 1 plus R, which gives us R minus 1, which is this line over here. To be more specific, this cell over here. And this is how the algorithm works. And we are going to go like this one, then this one, then this one, then this one. It works basically the same for all the directions. So we have here, let me draw this so that I help you to understand better the algorithm. And here it is. So if we are going to this direction, we have here R plus 1, and here 8 minus C. Here what I'm trying to explain is, what if we go to this direction, and it stands exactly for the choice of 4, R plus 1 and 8 minus C. I'm going to explain from where I get these values so that you can understand basically how the algorithm works, and you can maybe based on this, on my idea, you can think of your own algorithm and solve this problem in your own method. And this is the best thing that you can do if you face the problem in any algorithm. And it's not a bad thing to learn from other people's solution, but the best thing is that you can learn from other people's solution, and then try to make your own solution, try to think in a better way. Believe me, there is some contribution that you can make to any solution. It's some change. I don't care how small it is, but you can do it. And that's how we learn. So trust yourself. Let me explain how this works basically. for me here, the range in this case starts from 0 to math mean r plus 1 8 minus c. So let us go and open this one like this, and this one here, so that we can see better. So we are starting from 0. I are going in this direction. So to do so, every single time we are going in this direction here, we are doing the same operation on rows and on rows and on cells and on columns. The thing that we are doing is that we're adding 1 to the coordinate for columns, but for rows we are subtracting 1. That means we are here, if we have for example here we are in the line 5, we are going here to line 4. However, we are going to the column if we were also here in the column 5, we are going to the column here 6. So minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 sorry, I did it wrong. So I mean here is minus 1 plus 1. You can see it now. We are going like this. Minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. And this is how basically we can do it. Why I picked the mean? Because we have, don't forget, this board is square. So no matter which place you are taking, when you start from, for example, from this point, you are end up here in the mean of the distance that you are given here or here. You are going to be more clear, if you are going up, you are going exactly in 1 2 3 4 5 times. You are going to exactly 4 cells up, and here we are going 1 2 3 4 cells. All right. So the thing that's going to happen, if you pick this place, for example, you are going to go 3 2 and 2. If you pick it, for example, this place, you are going 1 and not 6. You are not going here up 6, you are going just 1. You can see it, you are going just 1 cell. So every single time, just try it and you will understand it by yourself that you are going by the minimum. You know, the minimum distance is the distance given. So this is basically the thing that I did. I started from 0 till the mean of the given distance. The given distance is started from r plus 1 to, if we are going for the rows, and 8 minus c for the cells, for the columns, sorry. And the thing that I'm going to do here is that each time I go up, the number for, or the index of the row gets lesser by 1 and gets higher, or it grows by 1 for the columns. The columns grows by 1 and the rows shrinks by 1. You can see this. So this is basically the idea of the algorithm, so that you can go into this direction and you can go into any direction. Now, taking in consideration that you have a linked list for any direction that you want, the next thing that you are going to do is to check if the move is legal for each direction. So that's what I do. So if we have a linked list that has a size less than 3 or inferior than 3, this means that there is no possibility to have a sequence in which we have 2 colors and two colors. This means 3. I want to say 3 colors: white, for example, black, white, and black, white, and black, white, black. So we need to have at least 3. The size of the size of linked list should be at least 3, and else the first thing that we are going to do is to remove the first value in the linked list. The first value in the linked list is the dot, is this one, the dot. So we are going to remove it. We don't need it anymore. Next, we are going to iterate over this linked list that we got, and then we are going to check if the value that we got equals dot. This means that we find a blank or free place here, This means that it's entirely impossible for us to have a sequence of the same color and then the different color. We shouldn't have a free cell, so immediately we are going to return false. This is the algorithm, how the algorithm works. And then this is what we are asked to do in this exercise. And then if we get the same color as the one that we picked here, this means in this case we found the one we picked here is black. If we found black, that means that it's true. If we found the right color, that means we are going to return true, and thus we are going to return finally the correct value, which is true, and we are going to say that this move is legal. Otherwise we are going to return just false, because we didn't found a blank cell, and we didn't found for the entire line, we didn't found the same color as we have. This means that we found something like this: a black, white, 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 and white. We didn't find the black again, so finally we are going to return false, because this is not a legal move. So this is in general how we are going to check for the move for one direction. And you can guess it already that to check the move for all direction, it's basically so easy, because what we are going to try to find is for one time at least, for one direction, the move is legal. This is what we were asked in the algorithm. So we are going to do OR. We are using OR here, the logic operator OR, so that we're gonna check for any direction. So this is the first one, second direction, third direction. This is how the algorithm works. And to see basically that the algorithm works, I'm going to use here a set of tools that helps me too much with competitive programming, which is the debugging tool in VS Code. The testing and debugging tool in VS Code. So basically this is the code that I'm going to run is this one. Is a simple set of unit tests that I made. Check move for the first board example, another example, third and fourth, and so on. We have 8 examples, so that we cannot check we can fully check the algorithm. So this is it. And the thing that I'm going to do is I'm going to use some breakpoints in every. I think that I'm going to use only breakpoints here for one case, just this one. So let's go and run the tests. I think that I'm going to run only the first one. I'm going. Oh, I run it. I wanted to debug it so that I show you what happens in this algorithm. So debug test. All right, and here we go. The algorithm stops in this breakpoint. So the thing that I'm going to do is that I'm going to go into this check move one direction method to see how it works. But before, I'm going to go to the rotate matrix method, and we are going to see exactly how this method works. So we created a linked list which has the size 0. There's nothing, it's an empty linked list. We're taking this board which has these values, as you can see. We don't need to see them, they are here. It's just an example. So the other thing is that we are given the row 4 and the cell 3. So, and the round 0, we are here in round 0 in case of round 0, because that's the breakpoint in which we stopped in case of round is 0. So the thing that's going to happen is that we enter this case. After this line, the thing that's going to happen is this. As you can see, we quickly filled the linked list. we are going to see the values that we have here in this linked list. We have the first value dot, then w, 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 and b. Let us check here this example. I'm going to change the code somehow so that it will be so easy to read it for us. Okay, and perfect. So we are here in line. Basically, as you can see, this is the matrix that we have, or the board we are given. We are here in row 4, column 3. Sorry. We are here exactly in this point, and we start from this direction, and we are taking dot, then w, 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 and then finally b. Now this is our linked list, the linked list that we are going to work on. We return this linked list, then we are going to see what's going in to the other method of the second method, which is check move one direction. Let us go into this method. Here we are. In this method, we have here the linked list, the previous one. We have 4 and 3, the coordinate of this point, the given point, and the color, which is black, b. So we are going to check if the size of the linked list is inferior than 3, and basically the size of this linked list is 5. You see, size equals 5, so each one returns false at this point. Next is we are going directly to else. We are here in list. The first thing that we are going to do is to remove. We're given this linked list. The thing that we are going to do is to remove the first letter in this linked list, which is dot. Now the size of the linked list is 4, and we lost the first dot, and everything moves easily. That's why you may ask me why I picked this type linked list for this algorithm. And this is another the thing that for which I like Java, is that it offers many types and many methods, and it's basically my own choice, my preferred choice of programming languages in competitive programming. I'm not just saying for you to work with Java or anything else. I'm not sponsored by Oracle or something. No, I'm saying that I prefer to work with collection. It is easy for me. I have a long experience with this, so I like it. Now that we removed the first, we can do this in C or C++ easily. I know it's not something special, but here for me we removed the first letter, which was dot. Now everything moves smoothly, and immediately the W took 0 as index. So we are going to move now to the next line in which we stopped, which is this one. In this line, what I'm doing is I'm defining a char variable or character named wave color. This wave color here, this expression returns the opposite color. This means that we are going to check if color equals white, then return black. If colors is different than white, then returns white. This means that ref color will take the opposite color than the color. So as you can see here, we have ref color as W, while color is B, black. So we are going to continue here. We are going to check if the first letter or character in the linked list is the opposite of white, which means the opposite of ref color, of color, which means it equals ref color. In this case, the thing that's going to happen is that we can continue to do checks. Otherwise, we don't need to check anything, because if we didn't find immediately a different color than the one given, this means that this is not a legal move. to give you a clear idea why this is not a legal move, you need only to go back to these two examples, and especially or precisely to this one. This is not a good line because we have white, white. We need something like white and then black immediately, and that's why we do this if else, this condition. Now we are going to remove first again, because this check is success in our case here. As you can see, take a look at this one, it will go. As you can see, we deleted the first line, which means that we only have now white, white and black. We in the next thing that we're going to do is here in this for loop. Now, as I said before, we're going to check check these conditions. If these are valid, we have v equals w. This means that we are not going to enter here and return false. We are going to check if v equals w and color v equals w, and we are going to check, sorry, if v equals color, v equals w while color equals black. So we are not going to return true. We are going to the top of the linked list, of the for buckle. We are going now to check in the second case here for v equals, we are here for v equals w, and we are going to continue. The same thing will happen, and now we have v equals black b. As you can see here, v equals black. So we are going to check this condition went successfully, so or will go successfully, so we're going to return true. Now the first test result 0, if I go like this, returns true, as you can see. So everything basically next will go as I showed in this example, and we're going to get this true, false, 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 and then as you can see we have true, true, false, 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 and false. It's exact same example here. This is the example that I ran. We have true, then false, false, and then we have false, 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 and false. This is what we did here. The final result is going to be true. So finally the test will succeed. As you can see, the test is succeeded. So we got here this green check, means that the test is succeeded and the algorithms works finally. So this is it for this video. I hope you liked this algorithm or the way I explained this algorithm. If you have any remarks for me, or in the method that I use to explain, if you have any remarks for me or you want to tell me something, please feel free to write down in the comments below. I will be happy to answer all of you, and thank you for your support. But before we close up this video, I'm going to submit this code to check if it works and to check how much time it takes. So it takes 6 milliseconds. It's not that much fast. When I submitted in the contest, it took way too much time, but the memory usage is slightly better than 60% of Java submissions. So